I wanted to cover these because we didn't get to cover them in class, so let me show you how to do these. The derivative of cosine inverse of e to the x. If it was just the derivative of, cosecant inverse. If it's just the derivative of cosecant inverse of x, that's easy. That's -1 over the absolute value of x, square root of x squared minus 1. But since it's d dx of the cosecant inverse of some junk of e to the x, then its derivative is -1 over the junk, absolute value of the junk, times the square root of the junk squared minus 1 times the derivative of the junk. The derivative of e to the x is e to the x. So we get this. The e to the x is on top. On the bottom, absolute value of e to the x. E to the x is always positive. It graphs like this. It never drops below the x-axis. It's always positive. So I can drop absolute value. E to any number is a positive number. So I can drop absolute value and I get e to the x. I still have this -1 on top, so it's really a negative e to the x on top. And the square root of e to the x squared minus 1. These two divide to 1, so I'm left with a -1 on top. Square root of e to the x squared minus 1. And if I look at my answers, none of those are quite there. D is the closest, but here's what they did. They factored out an e to the x squared from these two terms. It's called a force factor. So I'm going to write equals -1 on the top. On the bottom, I'm factoring out e to the x squared from both terms. So I got e to the x squared times parentheses 1 minus 1 over e to the x squared. And notice if I multiply back through, e to the x squared times 1 is e to the x squared, just like we have. And e to the x squared times 1 over e to the x squared gets me back to the 1. So it's a force factor. I'm forcing a factor out of this second term. Again, e to the x squared times 1 is e to the x squared, which is this. And e to the x squared times 1 over e to the x squared gets me back to the 1. Alright, so force factor. Square roots are distributed through factors, so I have a -1 on the top still. Square root of e to the x squared is e to the x. And underneath the radical, I still have 1 minus 1 over e to the x squared is the same as e to the 2x. Power to a power you multiply. And that is choice D. Very difficult manipulation, but choice D. Alright, number 2, or number 7, second one. So this is the equation for a tangent. This is an equation, not just the tangent, but the equation for the tangent line. To the graph of y equals arc sine of x over 2. So arc sine of x graphs like, see, here's the sine function. So the arc sine looks like this. It's a mirror image over the y equal x line. And arc sine of 1/2 x is going to be the same. I could just change the scale and actually make it look exactly the same. It does go through the origin. Remember, if we have our little table, x, sine of x, if x is 0, the sine of 0 is 0, which means the arc sine of 0 gets me back to 0. If I put a 0 in for x here, I get 0 divided by 2, which is 0, and the arc sine of 0 gets me back to 0. So 0, 0 is on the original function, and it's also on the tangent line. That's the definition of the tangent line. It's touching at a tangent point. So we're actually trying to find the equation of this line. All right, and the line and the function both go through 0, 0. All right. So to find the equation of that line, we need a point and a slope. We've got the point, 0, 0. We need the slope. You find the slope with the derivative. So we want to take y prime and evaluate it at x equals 0. So y prime, the derivative of arc sine of x over 2, is 1 over the junk, 1 over the square root of 1 minus the junk squared, x over 2 squared, times the derivative of the junk. The derivative of x over 2 is 1/2. That gives me 1 over the square root of 1 minus x squared over 4 times 1/2, which puts a 2 right here in the front. I'm evaluating that at x equals 0. At x equals 0. Okay? So put a 0 everywhere I see an x, I get y prime of 0 is 1 over 2 times the square root of 1 minus 0, which is 1 over 2. So that's the slope of my line. This is the point, 0, 0, that my line crosses. If you use y minus y sub 1 equals m times x minus x sub 1, you'll get y minus 0 equals the slope 1/2 times x minus 0. So y equals 1/2 x. I look over here at my answers, they have it in standard form. So I have to take the 1/2 x to the left-hand side. I get negative 1/2 x plus y equals 0. Standard form, you want this first constant, this first coefficient in front of the x to be positive, and you want it to be non-fractional. So basically I'm multiplying both sides by negative 2. Negative 2 times negative 1/2 x is a positive x. Negative 2 times positive y is negative 2y, and negative 2 times 0 is still 0. That's the standard form for the equation of this line. X minus 2y equals 0. Choice A. And real quick, let's look at Desmos arcsine of x over 2 and x minus 2y equals 0. Let's look at Desmos real quick. And y equals arc sine of x over 2. That's how it graphs, kind of how I sketched it. And the derivative was x minus 2y equals 0, or the equation of the tangent line. X minus 2y equals 0. And that is the equation of the tangent line. They both go through the point 0, 0. So there you go. The slope of that function at 0 was 1/2. And you can see the slope of this line, I go up 1/2 and over 1, rise over run. I'm sorry, up 1/2 and over 1. Up 1/2. Look at my scale right here. There we go. Up 1/2 and over 1. Up 0.5 and over 1. So that's the slope of that line. The slope of that line is 1/2. Good? All right.